Hi, we're Team Apollo 13 and we tried to build a hovercraft. So our task was to build a hovercraft, and as engineers we try to use the engineering design cycle, which is 8 steps that result in a product being developed. The first step is to identify the problem. Our problem was to build a hovercraft that could navigate a course. And then from that point we had to identify criteria and restraints which were outlined in the rubric they gave us in the project. It had to be powered by battery or AC and not gas. It could not incorporate commercial hovercraft parts. It had to move within a 1.5 foot wide racetrack that was 50 feet long. And it had to be turned with something on the craft and not be dragged or pulled. From then we had to brainstorm possible solutions to our problem, and from there we kind of tried to create the initial thrust. So we considered things like an air mattress pump, reversing a vacuum pump, a hair dryer, a motor and a propeller, and a computer fan. From there we had to generate ideas. All of the ideas kind of centered around creating enough lift to fill a skirt with air and create enough air pressure underneath the craft that it would lift off the ground. One idea of steering and propelling the craft forward was having 3 motors on a deck, right, left, and back, a skirt with air and create enough air pressure underneath the craft that it would lift off the ground. One idea of steering and propelling the craft forward was having 3 motors on a deck, right, left, and back. Another idea was just having a single motor on the back to propel it forward. From there we had to explore the possibilities. Each source except the computer fan didn't create enough airflow or was too heavy, so we just decided on the computer fan as our source of thrust. From there we had to select an approach as to how we were going to create this hovercraft, and we decided to have a computer fan fill our plastic bag for the skirt. And the skirt had holes in it, and we would have a single propeller on the back to create the force forward, and it was on a pivot joint so it could be turned and adjusted. From there we had to build a model or a prototype to test our ideas, and our initial design was to have with the computer fan in the center of the craft, but it didn't work because it was too heavy because of the metal frame, so that was a problem we had to address. From there we refined the design by cutting the frame off the fan so it would be lighter, which did help it lift a little bit more. We also had to adjust the skirt several times because it wasn't pressurizing fully, so we changed the size of the holes, the adjustment of the bag. Our final design that we used at competition had a bottom layer of styrofoam because the styrofoam was light. Then the computer fan, then 2 inches of styrofoam above the fan to create a tunnel effect. And it drew the air in and created enough pressure, but unfortunately we never were able to get it off the ground. So what were some design challenges that you guys faced with building a hovercraft, and how did you deal with them?
Well, one of the biggest problem was creating the lift for the hovercraft, actually getting the craft to hover. So what we decided to do was to use a high-power computer fan that sat above a hole in the deck, and we had a vacuum bag wrapped around the deck, which would fill with air once the fan was turned on. We had holes cut in the bottom of the skirt to create jets of air to let the air escape to keep the pressure normalized. Another problem was creating forward thrust, so what we ended up doing was placing a motor on the back of the craft with rotors to just push the craft along once it was hovering. And we also used that motor to solve another problem we were having, which was turning the craft. So we decided to make the motor pivot, change the motor whichever direction we wanted to go. The final problem we faced, which is a problem that I'm not 100% sure we actually ever cleared. I think it looked nice, but we had to make the craft appealing, visually appealing. So we tried to make it as symmetrical as possible, lined up all the pieces nicely so that it was aesthetically pleasing. And we colored it nicely, colored it red, of course, go Pack. And those were the problems that we faced with the hovercraft.
So the purpose of this whole project was to be a competition, so we competed against all the other sections of E101, and well, we didn't exactly do very well. We didn't move past the start line except for me dragging the extension cord, but besides that we did pretty well. We got third to last place, so we didn't get last. We beat a team somehow. Not really quite sure how that happened.
So, since you guys didn't really fare all that well in the competition, what would you do differently if you had to do it over?
Oh, well, I think I will first consult the guru more because they are more experienced than we are. And second, I will not order products online because it is difficult to tell for sure what you are getting. And we ordered a computer fan online and it ended up getting a metal fan instead of plastic.
So, what's some advice that you would give freshmen next year if they get this project?
First off, quite obviously, you should start the project early. It's going to take a lot of time, more than you probably expect. Also, you should start early because mistakes are going to happen. You're going to mess up. Something's not going to work. It won't go the way you want it to. It's just going to happen. You really need a good plan to start with, but you can't have it carved in stone, and that's the only way you're going to do it. You have to be able to change your plan and be flexible depending on what your group members recommend. Also, you should probably talk to the guru. They're pretty smart people, a lot smarter than I am. They know this stuff a lot better than you will.
Yeah, you'll be like, holy fuck, you'll feel so much stronger than you really are. Really? Yes. If I like fucking drag you, fucking chest. Because I feel like a fucking unstop. Alright. Abby's trying it.